A very good morning to all and welcome to our D2 Session 3 MIT 2020 conference. In today's session, our chairperson is Dr. Ravi Shankar Dubey. He is Associate Professor in Department of MIT School of Applied Science, MIT University, Jaipur, Rajasthan. He has earned his PhD in study of fractional calculus and fraction of several variables from University of Rajasthan. He has completed MSc in mathematics from University of Rajasthan in 2006. He has published several research papers in reputed journals. He has attended several national and international conferences and invited talks. He is reviewer and editor in for various conferences and journals. Of Rajasthan Giant Parishad, University of Rajasthan, Jaipur. He is author of book of Engineering Mathematics, published by Saroj Publication, Jaipur. Welcome, sir. Welcome, sir. Very thank you to present here for chairing our session. Now we start. Now, can we start our session, sir?
Thank you. Thank you, ma'am. It's my pleasure to be a part of this well-known conference, and I welcome to all the participants who are going to present his presentation here. So you are permitted to start the session. Let's start.
Now I would like to call our first candidate for presentation, Akanksha Shukla, with P71 accept number.
Thank you, ma'am. Can I share my screen?
You can share your screen, ma'am.
Okay, thank you, ma'am.
Allow.
Ma'am, is it visible? Ma'am, my screen is visible or not?
The screen is not visible.
Okay.
Not visible.
Your screen is visible, but not the presentation.
Yes,
Now it is
Okay,
visible.
okay.
Same.
Okay. I think now my presentation is visible.
Yes, yes.
Okay.
You can
Good-
start.
Good morning.
Your presentation time is 10 minutes and 5 time for question answer session.
Okay, ma'am. Thank you, ma'am. Good morning, ma'am and sir, and all dignitaries and all the participants. I, Akanksha Shukla, is a PhD scholar under the guidance of the Dr. Kanak Modi ma'am and co-guidance of Dr. Shalini Shekhawat ma'am. And today I'm going to present my PPT on the partial derivative of multivariable incomplete function. This is my topic. Now coming to the abstract. In this paper, we have discussed some incomplete H function with multivariable incomplete H function by using the partial derivative on reducing these parameters, these formulas present on the large variety of incomplete functions such as incomplete gamma function, right function, and many more generalized function which are in form of incomplete or any other form, generalized form, where we can use in this research paper for the further investigation. And coming to the introduction part, we have studied many of the papers in such as Srivastava papers is also studied. In this paper, we have study about the incomplete hyperdemetric function, gamma function, and incomplete H function. Then after in this paper, we have study about how the I function is applied in the partial derivative functions. Then after we applied incomplete H function in the partial derivative with respect to X and Y. Coming to the prerequisites, we have studies I have already told that we have studies from the Srivastava paper, which is incomplete gamma H function. This is the formula and the contour integral formula for the incomplete gamma H function, where phi and psi are also defined with their series form. These are the basic conditions given for the incomplete H function. Similarly, we can define the incomplete gamma variable H multivariable for the H function, where this is the H function formula for incomplete gamma variable H function. We also have used Bessel-Matlaet function, which is this is the series representation for the Bessel-Matlaet function, We also have discussed the generalized Bessel-Matlash function given by the Singh and Gayasuddin and Khan also. We have used as a Pocamber symbol as the formula in this research paper. This is the Bessel-Matlash function, generalized Bessel-Matlash function exactly given by the Khan et al. And coming to the main result, what we have done in this research, actually, we have taken the partial derivative with respect to x, and by the multiplication of the incomplete h function and the Bessel-Matlash function, which is given in the left part of the theorem first, and then we find the result. Coming to the proof, we have taken the partial derivative function, multiplication of the incomplete h function and the Bessel-Matlash function as taken in the left hand side of the result. We bifurcated this multiplication, incomplete h function and Bessel-Matlash function. Then after, we use the formula of the incomplete h function in this contour form. After that, we applied differentiation dx, which is the differentiation with respect to x, applied in the multiplication form, which is first into second differentiation. Then next step is find by the using the differentiation first and then plus differentiation second. Coming to the point where last step. Coming to the last step, we have discussed the all common part is bifurcated, and the in bracket form we have taken our remaining part. This is the formula as we have already known in the special function. This is the formula for the gamma special function. On applying this formula, we can find main result, which is of the theorem 1. Similarly, as this was the with respect to x, for the next theorem we can find with respect to y, where the partial derivative with respect to y, and same function incomplete h function and multivariable extended Bessel-Matlash function. We will solve this theorem also in the same manner as the theorem 1. Only the difference is that this theorem result is proof for the partial derivative with respect to y. Theorem 3 is also same for the function which is incomplete h function, Bessel-Matlash function. Difference is that only that we have used the function before the partial derivative. We will use same process for as well as theorem 1. Similar process will be for theorem 3. Coming to the theorem 4, this is the same for the derivative with respect to y, but we have used this function fx plus gy plus h just before the partial derivative with respect to y. And the solution of theorem 4 will be same as theorem 1. Coming to the special cases, what we have discussed actually is we have used the incomplete h function for the two variables such as u1 and u2. As in the main result, we have taken the multivariable incomplete h function. But in the our special cases corollary 1, we have taken the two variable h function and solved this corollary same as the theorem 1, which is the procedure used in the theorem 1. And coming to the corollary 2, we have taken the incomplete h function for the single variable. But as we have already discussed that we have using the multivariable h function for the main result, corollary 1 for two variable and the corollary 2 for the single variable incomplete h function, and procedure is same as the theorem 1 or any other theorem. These are the references using in this research paper. Thank you.
Okay, Akanksha, it's a nice presentation.
Thank you, sir.
Akanksha, what is the topic of your PhD?
So generalized F function.
Generalized H function. Okay. So you have used here incomplete functions, is it?
Yes, sir.
Okay. What do you understand by the incomplete gamma function? Can you explain?
So incomplete gamma function is as a generalization of the gamma function, which is in form in defined in the series representation.
In the form of series representation. There is a difference between the gamma function and incomplete gamma function. Is there any difference? Have you read it?
No, sir.
You have to watch it. And speciality, like what is the difference between the gamma function and incomplete gamma function? Okay, as you told that there are two type of incomplete gamma function. Reason is that
Yes, yes, yes,
if you
sir.
go for the definition of gamma function, the limit will be running from 0 to infinity.
0 to infinity.
Okay, and the
Yes.
definition of if we go for the incomplete gamma function, it will be in the form of Fredholm integral.
Yes, sir. Yes, sir.
Okay, like your limit will be running from 0 to x, yeah, x to infinity.
Yes.
Okay, so this is the difference between that. Okay, and what do you understand by the singularity?
Yes, sir.
What do you understand by the singularity?
Similarity.
Singularity. If we have some analytic function, then what do you understand by the singularity?
Sir, I am not recognize your voice.
I want to know that.
Similarity between, sir.
Yes, similarity. nahi, I'm asking about the singularity. Do you read about the singularity?
Similarity, sir.
No, singularity. Have you read it in analytic function?
Analytic function.
Yeah.
Yes, sir.
And there is a one topic we have read it, singularity.
Yes, 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 sir.
What do you understand by the singularity?
A point which a function taken as infinite value, we can say.
We can say that the function where the function is not analytic.
Analytic, that is singularity. I agree.
Okay. Have you read it because you have defining the h function here?
Yes,
Okay.
sir.
So have you studied that where the singularity of that function exists?
No, sir, I have not studied it.
You have to be watching because it is an important thing that where your function is not analytic. It should be clear in your mind. Okay. So make focus on that where your function is not analytic. Okay. Speciality is that if we go for the definition, your definition is depending on gamma functions.
Yes.
Different type of gammas. Okay. So where the gamma is 0.
Yes.
Gamma 0 is not defined. So we have the singularity at gamma is equal to 0. Okay. So these are the point where we found out the singularity. Okay. And if reach to theorem 2 just.
Just a minute. Yes, sir.
Theorem 2.
Yes, sir. Theorem 2. Theorem 2.
Just a moment. Here you have taken how many variables? In a H, you have using the capital X as well as the capital Y. Is it?
Yes, sir.
But I don't think so. Your right hand side having these variables. I think so. You have done some slight mistake here.
Sir, in left, right hand side, we have taken the capital X, capital Y, which is the notation actually. Capital X is equal to m comma n up to power n.
Okay, it is defined somewhere.
No, sir. This capital N X Y is not defined in this slide, but defined in the paper.
Okay. Next, thank you, Akansha.
Thank you, sir. Thank you so much.
So nice presentation.
Thank you, ma'am.
Now we move to Akansha, you can remove your slides.
Okay, okay, ma'am. Thank you.
Now we move to our second presentation, that is P134, Jyoti Geetesh Prasad. Yes, you can share your slides, Jyoti.
Yes, ma'am. Am I audible?
Yes, you are audible.
My slides are visible, ma'am.
Yes.
So good morning, everyone. Good morning to Ravi sir. Good morning, Kanak ma'am, and all respected faculties. I am Jyoti Prasad. I am PhD scholar under MET Jaipur, Rajasthan. And this research work which I am presenting is dedicated to solving nonlinear partial differential equation, which is a fractional differential equation basically. So the the title of my research work is Solution of Local Fractional Generalized Nonlinear Coupled KdV Kotevic-Drieveus equation using local fractional homotopy analysis method and Adamian decomposition method. The abstract is, in this paper, an effective and robust numerical techniques are applied for solving this typical nonlinear coupled KdV equation, which is written in a generalized form, and we are discussing the solution of these two methods and their comparison throughout. And to deduce result by both methods, afterwards we have compared the results. So in order to prove the competency of proposed methods, we have illustrated few examples in the paper. So partial differential equations are extensively important for engineering problems and sciences. So we can come across the presence of PDEs in many problems which are related to real world, especially non-linear system. But at the same time, solving non-linear system is a challenging task. So most of the real life problems are non-linear mathematical models. So research is more research is really required in this particular area. So this work is dedicated to solving very important PDE, which is non-linear coupled KdV equation. So this is the form of coupled KdV equation, which is written in a generalized form and non-linear form. So there are two equations together which satisfy this format of the system. So we are solving two simultaneously. That's why these are coupled KdV equations. Now, coupled KdV is very important equation if we talk about the application in the real world. When we do the analysis of nonlinear physical processes, the crucial part is study of traveling wave solutions for nonlinear equations. So there the KdV plays a very important role, and we can discuss wide variety of physical phenomena using this particular equation. That's why the focus of this research work is solving not only the single equation, but the coupled one, which is more applicable and appropriate for solving many real life problems. Firstly, it has been introduced by Bossinus in 1877 and then rediscovered by uh, Diedrich Kotevic in 1895. So this was the initiation by them. From there, researchers have been solving this equation, applying different methods on it. So here I have discussed the general methodologies or general methods which have been already applied to nonlinear KdV so far. So many researchers have been working to find analytical approximate solution of local fractional PDEs. They have been utilized methods such as local fractional Laplace transform method, local fractional variational iteration method, local fractional homotopy perturbation method, and Laplace homotopy perturbation method. So basically these all methods are very, very important tool to solve partial differential equation, non-linear as well as linear differential equations. So a study of these methods are really required in the process of solving non-linear coupled equations. In this paper especially, the work is dedicated to application of two methods basically, local fractional homotopy analysis method and the other one is Adamian decomposition method on this particular coupled KdV equation. So this is the format of equation where we can see two equations written in a general form and moreover non-linear form with some initial conditions. So firstly, I have applied LFHMHA method on it. So this is a description of the method. In the local fractional homotopy analysis method, which is very, very effective technique to handle all nonlinear phenomena and nonlinear differential equations. So what we do in that, first we create a mth order deformation equation where these are the details. The R suffix M is written by such in this format. Then this deformation equation, because this is a coupled equation, so we have written deformation equation for both of the equations together. And then we are substituting values of m one by one to get the answers in terms of series. So firstly, I substituted phi m equal to 1 to get phi 1, which comes out in terms of the initial value, means the preceding value, basically, that is phi naught and all, with their derivatives, fractional derivatives. So phi 1 is this. Finally, when I substitute phi naught value and all, we get this proper form of phi 1. The same thing I do in the second equation where the unknown is psi 1, and in that when I use the deformation equation and apply m equal to 1 value, I get this type of expression where mu is the order of differential equation, partial differential equation. Similarly, we go for other values of m, like m equal to 2, 3, and so on. So we have such type of phi 1, phi 2, similarly psi 1, psi 2. So continuously we are solving, iteration by iteration, we are solving the terms in the series. And finally, when we write in all the series together, this is the final solution. Phi in terms of a series, this is a power series. So values will be phi naught, phi 1, phi 2, and so on. This is clearly an infinite series. Similarly, psi also comes in terms of a power series. This is the methodology of this particular method, local fractional homotopy analysis method. And when I substituted the particular values in these solutions which I have achieved from these methods, it is comparable to the benchmark papers. Then the description of the other method, that is Adormian decomposition method. Again, the same differential equation, generalized nonlinear KdV, coupled KdV equations we are using. And this is the description of Adormian method, in which we create such kind of operator form which has some Adormian polynomials. So we deal with this nonlinearity by replacing it by some polynomials, basically, which we call as Adormian polynomials. Then we write a recurrence relation in that, and again recurrence relation, which gives us expression in which we can substitute the values of r to get the values of phi in terms of a series. So when I substitute r equal to 1, I have the first part of the solution, which is phi 1, which is in terms of Adormian polynomials. So it will go on for the second equation as well. Psi 1 will comes out this way. Similarly, we can find for phi 2 and psi 2 also. And again, the solution is in the series form. So these two methods I have tried to apply on the equation, and I have achieved the solutions which are matching to the benchmark paper. Because if I substitute the particular value, it will match to the standard results which have already been published. So basically the comparison of two methods are there in the paper, as well as solving the highly nonlinear coupled KdV equation is the objective of the paper, which we have achieved throughout this. Thank you so much. Ma'am, am I audible?
Yes,
sir.
Jyoti, nice presentation, ma'am.
Thank you.
Ma'am, I think so. First thing is that reference is missing in your slide. Whatever you have do, it should be indicated that where we have taken the respective references. It should be including that. Another thing is that you have taken a V is the order of the differential equation.
Yes, sir.
But I don't found that the domain range, whatever you have chosen for the B, is not indicated in your slides. So it should be included.
Yes, absolutely right. Sir, I missed it completely.
Okay. And tell me, you have uses the coupled KdV.
Yes, sir.
Can you tell me what are the applications of coupled KdV you have? Where it is being used?
So basically, the applications are in the various fields. Like one of the application I have mentioned in the slide, that is handling these traveling wave solutions, which is a part of mechanical engineering. So in the structure problems, we find such type of waves So there for the fluid solutions, they need to write the equation in form of coupled KdV. So this is one of the example, but there are many other as well.
Which software you are going to use for the calculation and plotting the solutions?
Sir, I am working on the software to plot it. I am working on MATLAB to plot these solutions. So work is still going on. I have just reduced the mathematical part of it, and I'm working on the MATLAB.
Okay, you have used the methyl Abla function here.
Yes, sir, as an initial condition.
Have you know that it is the generalization of which well-known function?
It's a generalization of exponential function.
Got it. Very good. Thank you, Jyoti.
Thank you, sir. Thank you so much.
Very nice presentation. Is there any other queries from participant sides also? Yes, any queries? No? So thank you, ma'am.
Thank
You
you.
can remove your slides.
Yes, sir.
So now we move further to the presentation number 78, P78, Radhika Kandhare. Please share your slides, Radhika. Radhika Kandhare. Okay, so we move to our till she is joining. We move to our next presentation, which is P120 Taylor Gomti Ben. So Gomti, you can share your slides.
Yes, ma'am. Can you see the slide, ma'am?
Yes, they are visible. You can maximize them by pressing P5.
All done, ma'am.
You can just press F5 and you can maximize it.
My screen is full screen.
Full screen. Okay, you continue.
Okay. Good morning, all of you. My presentation topic is analytical solution of generalized heat equation by Q homotopy analyzed transformation method. My paper number is P120. My name is Taylor Gomti Amit Kumar. My supervisor is Ravishankar Dubey. Co-supervisor is Vinod Kil sir. Now I'm going to start my presentation, which is the abstract of this paper. The goal of this project is gain the series.
Gomti, slide is not moving.
8 minutes, sir. 8 minutes, sir. Eight minutes, sir.
You can select from left hand side also.
Working. अब दिख रहा है सर? सर अब दिख रहा है?
No, first slide only.
Yeah, it will be changed. Just by clicking, you can also change it.
Okay, okay.
Doing
now,
the same way.
Now, the abstract wali slide दिख रही है, sir.
Yeah, of course.
Okay. Thank you, sir. Now, can I start, sir?
Yeah.
Yeah, thank you, sir. My name is Talar Komti. I'm from Gujarat. Now I'm start my presentation, which is the topic of my presentation topic is analytical solution of generalized heat equation by Q homotopy analyzed transform method. Which is the abstract. The goal of this project to gain the series solution for the fractional differential equation with Q homotopy analyzed transform method. The Q homotopy analyzed transform method can be developed in a better way. The Q homotopy analyzed transform method is computational, very efficient, nonlinear fractional differential equation arise in a real life problem. A number of numerical examples are provided to help you understand the concept efficient of the proposed technique. The numerical solution in the form of a series solution, the results are achieved. We will get the series of solution for that, and we will also get way better result. This method is effective, reliable, and feasible. Introduction of this Q homotopy analyzed transform method, which is the very useful method in last few years. Fractional calculus has become the center of many studies because of its broad application in mathematics, physics, and engineering, such as the electromagnetism, fluid mechanics, signal processing, hydrology, fractional kinetics, electrokinetics, etc. The concept of the fractional calculus debate on 1695 and was the firstly put forward by William D. L. Hospital. And next one is the Q homotopy analyze method, and it has been effective employing to find the solution for the problem arise in science and technology. Homotopy analyze method is based on the construction of the homotopy which continuously deform an initial basis approximation to the exact solution to the given problem. We will use here the homotopy analyze method. The Q homotopy analyze transform method was proposed by the Singh at al and which is the elegant amalgamation of the Q homotopy analyze method and Laplace transform. I will take the here the equation of the Q homotopy analyze method solving. Solution involves with the two auxiliary parameters h and n, which is the del raised to alpha u upon del raised to t raised to del t raised to alpha, which is equal to del x f of u del of u upon del of x. So due to the
Gomti, reach to your results.
okay, which is the model of the Q homotopy analyze transform method, which is the method. We can take first Laplace transform, then non-linear operator divide in expanding of the Taylor series, and is get where is the 1 upon m factorial del raised to m in P form. In equation Q is equal to 1 upon n. Then simplification this way, Laplace transform, then R of m, K of km. Then now taking inverse Laplace transform, then using the initial guess defined in equation 1.2, and we get u1. Then by m is equal to 2, put the m is equal to 2, then u2. Then substituting in this way, we can find we put all the value u1, u2 up to so on in the equation. Then we obtain the solution of the given equation. Now here see that the application of Q homotopy analyze method. Here 5 application. First one is the fractional heat equation, which is the equation of the fractional heat equation and initial condition f of u is equal to 1. Then similarly we can see that the method of Q homotopy analyze transform method. First of all, initial condition is a phi of x is equal to sine pi x. Then u0 is the sine pi x. Then we apply the method of Q homotopy analyze method. Then we find U1, U2, U3, U4, and so on. Then put all equation in main. Then we find U. Same, the second application is the fractional heat equation from the equation, which is the second heat equation, and here the initial condition is the P of x is equal to x square. Similar way, we can use Q homotopy analyze transform method, U0, U1, U2, and U3 up to so on. Then we find the general solution of the heat equation. Now, third application is the fractional diffusion process from the equation, which is the diffusion equation, and initial condition is the P of x is equal to x, and we apply the Q homotopy analyze transform method, and we can find the U0, U1, U2 up to U3 up to so on. Now the fourth application is the same, the diffusion process equation, which is the different equation from the other, and the initial condition is the P of x is equal to e raised to x. Similar, we can apply the Q homotopy analyze transform model method, U1, U2, U3 up to so on, then put the value, and we can get U general solution. Now third one, which is the fifth one application, which is the diffusion equation, which is also different for the another diffusion equation, and which is the initial condition is the x plus b divided by 2c, where c is a constant. Following, we can apply the Q homotopy analyze method and find U0, U1, U2 up to U3, and so on. Now I'm conclude that we develop an analytical solution for the nonlinear diffusion equation in this study. Our results show that Q homotopy analyze transform method can be used in a variant of complex situation, linear and nonlinear partial differential equation. Thus, we can conclude the Q homotopy analyze method is a more powerful computation tool for the investigating fractional problem, making it a superior of homotopy analyze method because of the choice of suitable values of n and h, which is the references for this method model. I will use these references. Thank you, sir.
Okay, it's nice presentation.
Thank you,
Gomti, you use heat equation here.
Yeah,
Is it?
yeah.
Can you told me what is the equation of heat equation for general form?
What's
Form. What is the general form of heat equation?
Which is a non-linear form.
No, it is a non-linear form. What is the general form? If I have talk about the ordinary derivative, what is the equation of heat?
Del Rey, like partial differential form.
Yeah, of course.
And non-linear form.
No,
partial differential equation, fractional form.
No, I'm not talking about the fractional. I'm talking about ordinary derivative form. What is the equation of heat? Heat equation is what? You have generalized it. Yeah. Obviously, if you take it alpha is equals to 1, then its equation
alpha
becomes
is equal to 1.
del u by del t is equals to del 2u by del x square. Simple, you have written this. Okay. And what tell me, you have using the Q homotopy method, correct?
Analyze transform method.
You have already HAM homotopy analysis method. What is the difference between Q homotopy and homotopy analysis method?
Which is the difference of H and auxiliary parameters.
Okay, the difference is what? Auxiliary parameter, especially
we can choose
Q is the Q
which
can
is
be
1 upon n.
This will be helpful for us the convergence of the series.
Q0 to 1 upon n.
Okay, Gomti.
Thank you, sir.
Thank you.
Thank you, sir.
Very good presentation. So,
Thank you, ma'am.
any other queries? So now Radhika is present here. So I will call upon for presentation number P78, Radhika Gandhare. Yes, you can share your slide.
Okay, ma'am.
Ma'am, my slider visible or not?
Yes, they are visible. Yes.
Visible.
Start. Working.
Good afternoon to all the dignitaries and the research scholar present over here. Here I am Radhika from BSc final year and the student of Shivaji College, Aput. Today I'm here to present my paper on the topic that is study of ground penetrating radar system for measuring, monitoring and modeling in agrophysics. Along with me, my team member is also there, Shraddha Shibukar. And first of all, I would like to thank my supervisor, Dr. Shrikant Nimkar sir, as well as Umar Bhati sir for guiding me throughout this research paper. And I would like to express my gratitude towards the convener of this program and the organizer of this international conference. Thank you for providing me this opportunity to present myself here. Thank you. Ground penetrating radar is mainly work in this agrophysics. Agrophysics is one of the branch of natural sciences dealing with the application. Sir, आतमध्ये जाऊ शकते. आतमध्ये जाऊ शकते. Agrophysics is one of the branch of natural science dealing with the application of physics in agriculture and environment for investigation, cultivation, and production. Physics plays a very important role. There are so many techniques used in the agrophysics investigation, such as root scanning, etc. But among all of these, we are just focused on only one technique, that is GPR, ground penetrating radar. It is geophysical technique to measure the underground parts, includes excavation and sampling using cores. It is most effective geophysical method and it is non-destructive and non-invasive method based on high frequency electromagnetic wave propagation. It has high resolution, ideal investigation, depth and high speed investigation that can be carried out during full traffic. It detects electrical discontinuities in solid surfaces as well as it used frequency from 10 megahertz to 2500 megahertz frequency center antenna. There are some objectives of this research. We just specially focused on very important technology, that is ground penetrating radar with respect to measuring, modeling and monitoring to study. Also to study the applicability of ground penetrating radar method in various applications as well as study of different center frequencies and resolution used in the various applications and their respective research. So these are the objectives of my research paper. Ground penetrating radar simply work on the basic principle, that is scattering of light through ground penetrating radar simply work on a basic principle, that is scattering of electromagnetic waves to detect the buried object. The data acquisition is performing in situ using GPR apparatus consisting of transmitter and the receiver antennas, the control unit and the digital recorder. The measurement is carried out directly on the surface and the transmitting antenna transmits a wave in regular interval into the investigated environment of the road construction. The signal is then spread within the investigated environment and some signal is reflected back and recorded by the receiving antenna. So this is the principle of GPR. In general, there are two main types of GPR antennas, ground coupled shielded antenna and air coupled horn antenna. Ground coupled shielded antenna, which are in direct contact with or up to the several centimeter above the studied surface during data acquisition. Also, air coupled horn antenna, which are designed to acquire data from a distance of a few tens of centimeter to less than 1 meter above the surface. So these are two types of GPR antennas. GPR unit transmit discrete short electromagnetic wave into a medium which reaches to an interface with different electric properties. Some waves are reflected back and rest of them transmit through the interface and proceed forward. The center frequency used by GPR is lies between 10 megahertz to 2500 megahertz central frequency. And reflected energy or modulated data is collected and displayed as a waveform in the form of amplitude and time elapsed between wave transmission and reflection. Several GPR time records A scan and regular interval along specified profile bonded together gives B scan or radiogram. I don't have performed this work practically, but I have just taken some images from internet because we don't have such type of instrument in our college laboratory to perform this experiment. So this is the overview of radargram which we will obtain after proceeding this procedure. A radargram shows continued recording of measurement along a profile. Radargram collect along given profile in X and Y direction can be stuck together and form C-scan or 3D radargram. Continuous data processing is carried out in the specialized software system and gives graphically proceeds at the end. So this is how this GPR work. Then methodology. GPR method generally used to reveal determinability of depth and position of different objects which is buried in the several places of a certain field. As we don't perform this experiment, so as I have reviewed some authors and study, according to my study, these are some systems which are used in the determination of buried object in a solid surface. So RAMX second plus ECOS GPS software system is also used, and the size of test site and the for investigation of spread fooding of concerned object using 250 to 800 megahertz center frequency antenna, which are capable with RAMX second system were used. The radargram obtained from the measurement were proceed using ReflexW software. Version 6.0.7 is used. After the processing data, this reflected or scattered reflection on the proceed radargram were examined, and radargram will interrupt to determine the depth and the position of the object from the surface. Also, the data obtained from 250 megahertz and 800 megahertz center frequency, as well as the various center frequency antennas were compared, and I have taken, as according to my study and the research papers which I have referred, I have collected some information and tabulated this information in the table. The table is given as on the screen. The summary of finding contains application and the respective method used by the respective authors for this investigation. In case of investigation of spread footing, the GWSI SR 3000 GPS system were used with the combination of ground coupled antenna of frequency 400 MHz, and it is studied by Michael Green. The payment condition and prediction of its degradation uses 2 GHz horn type antenna with GWSI SR 2016. Also in soil moisture, antenna of center frequency 200 to 800 MHz on slit clay by time domain data analysis method were used. In detection of buried object, 250 MHz to 800 MHz center frequency antenna with RAMX second system were used by the respective authors, respective researcher, and the detection of soil pipes, RAMX GPR system with 500 to 800 MHz center frequency and shielded antenna with the GPR receiver were used. Also, these are some application and the methods which are used by the respected authors. In measurement of mapping tree roots, GPR system, a GPR with signal frequency of 450 megahertz, a pulse echo 1000 GPR system were used. So these are some application and the respective method used for the investigation. According to my study, the conclusion obtained is that GPR is non-destructive, time-consuming, expensive, non-invasive method, but it is on-site measurement technique with accurate and complete underground information. The appropriate result obtained if and only if you use the high-frequency antenna, and very few result are obtained on low-frequency antennas. So our future work is to develop this GPR system so that it can be available on low cost as well as in low frequency antennas. So we can use it in a major way, and our future work is to develop this GPR system. So this is all about this GPR system, and these are my references. Thank you for listening. Have a good day.
It's a nice presentation. What is the topic of your research?
The topic is of GPR, sir. I am specially focused on the GPR system, which is used in agrophysics.
What is the agrophysics meaning?
Agrophysics means the physics which is used in agriculture.
Okay, agriculture. Okay, very good. It is your review paper?
Yes, sir. This is my review paper.
Okay. You have you can also compare the different respective models which are available. They can also can be compare with the system. It's also good for it. Okay. Have you studied what is the effect of the frequency? It will be give some particular, as you have used the particular range of the frequency in your slides. So, is there a certain effect of the frequency changes in the output?
Yes, sir. Definitely, sir. It is depend on the frequency used.
Okay. 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 Thank you.
Yes, Radhika.
Sir, I want to take one screenshot. Can I take?
Yes, yes.
Please open your. Please on your video, sir.
Direct in simple.
Thank you, sir.
Thank you. Thank
Can I leave, sir?
Sure. Sure. You
Thank
may
you.
leave.
So now we call upon our next participant, which is P107, Sarita Yadav. Sarita, you can share your slide.
Yes, ma'am. It's visible, ma'am.
Yes, it's visible.
Okay, good afternoon, everyone. I'm Sarita, research scholar, Banasthali Vidyapeeth, and my topic is performance optimization of CH3NH3SNI3 perovskite solar cell using Centarius TCAD simulation. These are the content, introduction, device structure, simulation methodology, result, and the discussion and the conclusion. Introduction. Energy shortage has become a global problem, and solar energy is a promising alternative to solve this problem of energy shortage, as it is a renewable source, and it is a pure that is a no harm to environment. Solar energy equipment are required as a part of long term of global energy strategy, and the perovskite solar cell has gained a significant consideration in photovoltaic application due to their low cost of fabrication, the lead toxicity, and prevent it from being used in a wide range of application. So effective lead-free perovskite solar cell must be considered as well as investigated. This is the device structure. The light stack, the FTO, and the CH3SN-I3 is used as the absorber layer, is the middle between the ETL and the HTL. ETL is the TiO2 layer, and the HTL is the P.PSS, and the FTO and gold are using as the front and the rear metallization contact. When the light strike on the perovskite layer, the electron from the valence band is excited to the conduction band and leaving hole in the valence band. The hole and electron are diffused and transferred to the into the ETM and the HTM, and the perovskite of the valence band and the conduction band and the valence band coordinate with the charge transport layer, and further effective charge transport through them, and the charge transport layer with a material having a high carrier mobility should, and the cathode and the anode electrode capture electron and hold, and then transfer to the external circuitry and the yield current. Table 1, these are the parameter used in simulation. simulation methodology. The drift and diffusion transport model is used for electrical simulation, in which electrostatic Poisson equation as well as continuity equation, both of the charge carrier, are solved repeatedly. This is a Poisson equation and this is a continuity equation. And for optical simulation, we use the optical intensity as well as optical generation rate, जो calculate है transfer matrix method. Result. And this is the energy band diagram of the perovskite solar cell, in which shown a spike is formed at the absorber layer and the ETL, like a TiO2 layer. So the spike act as the barrier from the photogenerated electron from toward the electrode. This is the JV characteristic. Electron and hole pair are formed after the illumination condition. Electron and hole all travel to ETL and the HTL as a result of the junction field, and a voltage is generated from the electron and hole accumulated to the anode and the cathode, and the JSC is achieved is 29.82 milliampere upon centimeter square, and VOC is achieved is 0.798, and fill factor 85.57%, and the power convergence efficiency is 20.38 according to the table 1 and 2, these parameter used. Influence of the absorber thickness. The absorber thickness has a major role on the device performance. So the thickness of the absorber layer are adjusted from 100 to 1000 nanometer. Yeah, you can say that in micrometer also. If you change these are the parameter, table 1 and table 2 other parameter will be constant, only absorber thickness will be changed. So according to that, the increase the substitutional value of JSC is achieved 31.84 is achieved when the thickness is 500 nanometer. यानी जब 0.5 and 0.5 micrometer you can say, that time जो JSC is achieved 31.84. It means in the perovskite layer has a large absorption coefficient. The increased recombination of the free charge carrier in the thicker absorber layer may be responsible to a steady drop in VOC also. And the higher series resistance could be explained and decrease the value of fill factor, and in increasing absorber thickness. PSC rise firstly in the peak is 21.28 when the thickness is 500 nanometer. You can say 0.5 micrometer. The maximum efficiency is achieved is at 500 nanometer. We can say. Yeah. The absorber thickness is lower than the charge carrier diffusion length. So therefore the majority of the charge carrier reach to the electrode, increasing to PSC, any power convergence efficiency. For thick absorber layer, recombination occur, and therefore the power convergence efficiency falls as the thickness increase. Conclusion, by optimizing the value of absorber thickness as 500 nanometer and the defect density at 1 into 10 raised to power 14 of perovskite material, so the maximum value of power conversion efficiency is obtained is 21.28% with the JSC of 31.84 and the VOC is 0.7987 volt and the fill factor is 83.66%. These findings suggest that this lead-free perovskite solar cell could be a valuable option for reaching high efficiency while being toxic free. Thank you so much.
Sarita,
it's
a very good presentation. So, what is your field of research?
So, lead-free perovskite solar cell, simulation of lead-free perovskite solar cell.
Okay, so these particularly cell which you are working, it will be not in the it is in the experimental form or it is in practically available in the market.
Sir, this is a simulation. Basically, मैंने simulation किया है.
No, you have doing the simulation, but
हाँ जी.
you want to increase the efficiency of, is it?
हाँ जी.
Okay. And what the particularly you have used the particular thickness effect, is it?
हाँ जी.
So what will be the outcomes you have found it when you have increased the thickness or decreased
Okay.
the thickness? What will be happen?
When we increase the thickness, so then like more number of recombination occur.
Okay.
So at a particular frequency 0.5 you can see in diagram like, so maximum efficiency achieve.
Okay, maximum and your what is the maximum efficiency we have found it? It's approx
Maximum efficiency 21.28%.
21. It is doing in your experiment. Have you found that these result in your experiment? Is it?
This is just a simulation result, sir.
Simulation result. You have not done it particularly. You have just calculated just now. Okay.
In software, Centarius ticket software.
Okay. Thank you.
Okay. Thank you, sir.
Okay, Sarita. Good presentation.
Thank you, ma'am.
Yes, you can remove your slides.
Okay, ma'am.
Yes. So here we end with our today's session 2, first part. So I want to thank
Hello?
Ravi Dubey sir for chairing the session. Thank you, sir. And nice presentation to all the participants. Yes, thank you, Ravi sir.
Thank you, Ganak.
Yes, thank you. So we are ending the meeting. Thank you to all.